Okay, so today we're going to look at power. Now, this topic comes after you've done straight line motion and graphs and the kinematics, acceleration, forces and resultants, Newton's laws, friction, work, and energy. And it's very, very important that you know all those topics that I've mentioned before you can do questions on power. Now, power is quite a very, very interesting topic in mechanics. And to start with, when we're talking about power, we use the word power every day. So we're just talking about the rate at which you are doing work. So power, we're just talking about the rate at which you are doing work. That's what power is. We talk about power every day. You could have been given something to do by your parents. So we are also interested in how long did you take to do that work that you were given by your parents. I could have given you an assignment. The question would be, how long did you take to do that assignment I gave you? That's what the concept of power is. Now, power is calculated as work. This is the work done over time you took to do the work. That's power. Now, remember that when we are looking at work, we actually say that work was equal to force times displacement. That's what we said work is. We said work is force times displacement. Now, work is force times displacement. Remember, we have time down. Now, you know that displacement over time is velocity, okay? Displacement over time is velocity. So we can write the formula for power as force times velocity. Now, this is very, very important, guys, because each question that comes on power comes with certain things you are given. Sometimes you are given work. Sometimes you are given time. Sometimes you are given velocity, okay? Sometimes you are given other informations. So the information that you are given matters and is very, very important as you solve questions on power, okay? So, and one thing that you need to understand, which is very, very important, is that when you are solving questions, okay, when you're solving questions, either in an exam or you are going through some past paper, or you've been given a test by your teacher, or anything that you are doing, we are talking about questions in an exam, the first thing you need to do, so if you're answering questions in an exam, the first thing you need to do is identify a topic where that question is coming from. So identify a topic. After you've identified the topic, the second thing you do is look at what you are given in the question. Look at what you are given in the question. What are you given in the question? So first you identify a topic where that question is coming from. The second thing to do is you look at what you are given in the question. Then after that, now you can answer the question, okay? You identify the topic, You identify what you are given. And the third thing is, what formula are you using? Okay. After you know what you are given, you'll be able to know the kind of formula you are going to use to solve your question. Now, these things are very, very important as you answer questions, especially in an exam. So we've talked about what work is. We've talked about what power is. So let's try to answer some questions. So let's start with 2016 past paper. So if, so I'll go to 2016 past paper. And so all of you can see this past paper. All of you can see this past paper. This was May, June 2016. You can see. So we'll go straight to the question of power. So if we go to the question, sorry, I've gone somewhere else. So the question paper is here. This is a question paper here that we have. So this is a question paper that we have to answer. Sorry, this is 2017. Is it 2017? Sorry, I meant 2017. This is 2017 past paper. Okay, so this is a question. This paper was in 2017. So the question reads, one end of a light extensible string is attached to a block. The string makes an angle of theta degrees with the horizontal. The tension in the string is 20 newtons. Now remember, tension is force that is acting through the rope. So this is our force. The string pulls the block along a horizontal surface at a constant speed of 1.5 meters per second for 12 seconds. Now remember, this question is on power. We are given force. You can also see that we are given velocity, and we are given time, which is 12 seconds. And we are told that the work done by the tension in the string is 50 joules. So we are given work as well. And the question is asking us to find an angle. Okay. So like I said, the first thing you do is to identify the topic. Now remember, that question is coming from power, which is a topic. And the second thing to do is you check what you are given. The question has tension, which is the force acting through the rope. In this case, we are given as 20 newtons. We are given force. And then apart from that, the question has given us power. The question has given us, the question has given us work. The question has given us work, which is 50 joules. And then apart from that, the question has given us velocity, which is 1.5 meters per second. The question has also given us time, which is 12 seconds. And from the question, it says one end of a light in extensible string is attached to a block. Is attached to a block. So you have a block here. Okay. And then it says one end of a light in extensible string is attached to a block. So you have this string here. This is what you have. The string pulls the block along a horizontal surface. So this block is here. Okay. And the question again says, it pulls the block along a horizontal surface at a constant speed of 1.5 meters per second. So 1.5 meters per second for 12 seconds. So the string pulls the block along a horizontal surface at a constant speed of 1.5 meters per second. So that means if we can put up a good sketch, we have something that looks like that. We are told the angle is, this is theta degrees. Okay, this is your tension, which is 20 newtons. That's what we have, 20 newtons. The speed is 1.5 meters per second. That's velocity. And then we are given work as 50 joules. That's what we have. And then the question is asking us to find theta. That's what the question is asking us to find. Okay, now remember this is 20 newtons here. Okay, this is 20 newtons here. And one thing you should always know, remember when we talked about work, we said work is equal to force times displacement. And to find work, this force here should be in the same direction with displacement. Okay, force and displacement must be in the same direction. Okay, now this is a block here. Now, if this is a block and it's being pulled, you know that it will be in this direction here. Okay, it is being pulled at this angle here, which is theta degrees. But what we know is that it will be in this direction here. This is 20 newtons. Okay, now we need to find force. Remember, we are given work, but what we know is that work is equal to force times displacement. Okay, let's find force. The force that we have here is this force here. We are looking for this force here, which is in the direction of this direction here, because when you pull a block, it will move in this direction here. So let's try to find that force there. Now, you have not forgotten, I'm sure, about this concept of SOHCAHTOA. The concept of SOHCAHTOA. Okay, we have not forgotten about that concept of SOHCAHTOA. How is it important? We want to find this side here. We are given this side, which is hypotenuse, 20 newtons. We want to find what? The adjacent. So we have the hypotenuse, which is 20. And we want to find the adjacent. So you can see that from SOHCAHTOA, it's this part here, which has adjacent and hypotenuse. So it now means that this that we want to find here, which is force, is going to be hypotenuse, which is 20 cos theta. We don't know theta. So 20 cos theta. That's the force that we have. Okay, so that is a force. Then after now finding force like that, we now go back to the formula for power. Remember, power is equal to force times velocity, or power is equal to work over time. So then we are given we are given work, we are given time, we are given velocity. So if we are using this formula here, we have found F as 20 cos theta. V, which is velocity, is given to us in the question, which is 1.5. That's what we have. Now, remember again, power is equal to what? Power is equal to work done over time. That's also a formula for power. So we are told work is what? We are given work as 50 joules. That's work done by the tension. And time is what? Is 12 seconds. Right? It's 12 seconds. So this gives us what? This gives us 42. So that gives us 42. That's what we have. So we have 42. Now, after finding power as 42, so you can now see that we have power, we have velocity. For force, we have that, and we only have cos theta. And we are going to find now what we are looking for. So power is equal to force times velocity. Power we have found as 50 over 12. Sorry, 50 over 12 is 4.2. This is 4.2, not 42. 4.2. So this is 4.2 is equal to force. We have 20 cos theta. V, which is velocity, is 1.5. So from here, we can make cos theta the subjective formula. So that's dividing both sides by 20 times 1.5. 20 times 1.5. Okay, so you see this will go. And so from here, we have cos theta is equal to 4.2 dividing 20 times 1.5. That's what we have. So we're going to have cos theta is equal to, with help of calculators, what are we getting when we say 4.2 dividing 20 times 1.5. So can use a calculator, and then you will have that 1.5. Then after we do that, the next thing that we have to do is to find an angle, which is theta. So to find an angle, now what you can do is we are now going to say theta is equal to cos inverse. So when this cos, so it will be cos inverse, then 4.2 dividing 20 times 1.5. And finally, you're going to find theta as 82 degrees. You should confirm. That is the angle that we're looking for. So that's how we find the answer. Okay, now this was 2017 past paper. Now always remember, power is equal to force times velocity. Power is equal to force times velocity. Power is also equal to work over time. Okay. Whichever you are using of the two depends on the information given to you in the question. If that is clear, we are going to move to another past paper and do a question on power again. Okay, so I'm going to 2019. So your job, guys, is to make sure that you look for other past papers and solve related questions on power. So this was 2019 past paper, and so this was 2019. So this is a 2019 past paper. And so question five was on power. So this is a question here. If you look at this question here, it says a cyclist is traveling along a straight horizontal road. So always, mostly in mechanics, always make sure that you do a rough sketch so that you'll be able to answer your questions well. So it says a cyclist is traveling along a straight horizontal road. The total mass of the cyclist and his bicycle is 8 kg. His power output is a constant 240 watts. His acceleration when he's traveling at 6 meters per second is 0.3 meters per second. Show that the resistance to the cyclist's motion is 16 newtons. Okay, so let's go and do this question. Okay, so this is now 2019 past paper. Question 5. So remember the question reads, a cyclist is traveling along a straight horizontal road. So this is a straight horizontal road. You have a cyclist here. So you have a cyclist there. And the question says is traveling along a straight horizontal road. The total mass of the cyclist and his bicycle. So both of them, the bicycle and the cyclist, their total mass combining, their total mass is actually 80 kg. His power output is a constant 240 watts. So power is equal to 240 watts. That's what we are given. 240 watts. Okay, so it says his acceleration when he's traveling at 6 meters per second is 0.3 meters. Okay, so this cyclist is going this way. And the acceleration is 0.3 meters per second when he's traveling at a speed of 6 meters per second, which is our velocity. Show that the resistance to the cyclist is 16 newtons. Now remember, you should know that there is a force here, okay, the applied force. And there's also an opposing force, which is the resistance. So we have this force here, okay, and also some resistance. Now remember, power is equal to force times velocity. That's what power is. The power we are talking about here is the power in this direction. That's the power we are talking about. So this force here is this force here. So we are given power as 240. So 240 is equal to force times velocity, but we are given velocity as 6 meters per second. Okay, so for us to find this force here, we divide both sides by 6. So we are going to say that force is equal to 6 into 240 gives us 40 newtons. That is a force. That is this force here. So this is 40 newtons. Okay, so that is 40 newtons. Now, after we found the force, we now want to find resistance, this resistance here. Now you see, that's more important that you get to know the concepts of forces, Newton's laws, resultant forces, friction forces. So from here, to find this resistance here, we are going to resolve forces horizontally. Okay, so resolving forces horizontally, remember we are dealing with this direction facing this side. So we're going to say F, which is positive because it's in the direction we are considering, minus R. R is in the opposite direction, that's why it's negative, is equal to mass times acceleration, because remember force is equal to mass times acceleration. Remember force is equal to mass times acceleration. Force is equal to mass times acceleration. Work is equal to force times displacement. Power is equal to work over time, which is also the same as force, times velocity. So remember these, you need to know these formulas here. So now that we are resolving forces horizontally, we've found F already as 40 newtons minus R is equal to mass. The mass we are given as 80, the mass of bicycle and the cyclist. Acceleration we are given as 0.3. So we can find R from here. So 40, this when I bring it this side, remember, I'm going to say minus 80, 0.3, and this goes the other side because it's negative, it will become positive. That's what we are finding. So from here, if you use your calculator, you'll find that R is equal to 16 newtons. And remember the question said that show that R is equal to 16 newtons. We've shown. So we've shown. That's what the question requires us to do. So we've shown that R is equal to 16 newtons. Okay, now that we have found R, we can go back to the second part of the question. What does it say? So show that the resistance to the cyclist motion is 16 newtons. We've shown. The second question says, find the state speed that the cyclist can maintain if his power output and the resistance force are both unchanged. Now remember the question says power and resistance are both unchanged. So resistance is still 16 newtons, power is still 240 watts. It says power and resistance are both unchanged. Okay. Okay, so let's go and find the state speed, which is the velocity in this case. So remember, power is equal to force times velocity. So let's go and find the answer. Power is equal to force times velocity. That's what we have. So we still have the same idea, the cyclist here. This is a cyclist here, okay? Remember we found force here, which was 40 newtons. This is the applied force that the cyclist is applying to make sure that he or she moves in that direction. There's an opposing force that we said was 16 newtons. Remember, the question says such or such informations unchanged. Okay, now remember, for them to be unchanged, okay, for them to be unchanged, okay, it means acceleration is 0. For them to be unchanged, acceleration is equal to 0. Okay, it's like this is constant, nothing is moving. Okay, that's the only time they cannot be changed. Okay, because for them to be changed, it's either force is bigger or resistance is bigger. Then you expect some changes. But the question says there's no change. So this equation here, which is force is equal to mass times acceleration. Remember, your acceleration is equal to 0. Okay, so force is equal to 0. Now, this force I'm talking about here, remember, is a resultant force. That's a resultant force. The force we're resolving, remember, horizontally, which is this F minus 16. Remember, the question says resistance and power are not changed. Resistance and power are not changed. That's why for force, I need to find, okay? So F, this is F here. So you forget a little bit about 40 newtons. Okay, you forget a little bit about 40 newtons because the question doesn't say the force is unchanged. The question says resistance and power. So F minus 16 is equal to 0 because acceleration is 0. So from here, force is equal to 16 newtons. Now remember, this is just one way of thinking or looking at it, that in a way that for them not to be changed, it means force and resistance must be the same. The applied force and the opposing force must be the same for you to say that there's no change. So force is equal to 16 newtons. So then we have power is equal to force times velocity. Power is not changed, so it's still 240. We have F, which we have said is equal to 16. So this is 16. So 16 times V. That's the speed we want to find. So from here, if you divide both sides by 16, you're going to have your V, which is the velocity or the speed they're asking us, as 15 meters per second. $15 meters per second. That's what we have. So that's the answer. We go to the third part of the question. This question says, the cyclist later ascends a straight inclined at 3 degrees to the horizontal. Its power output and the resistance are still both unchanged. Resistance and power are still not changed. Find his acceleration when he's traveling at 4 meters per second. If I do a sketch of that question, it says the cyclist later ascends a straight hill. So we have this. Remember, the cyclist was traveling along a straight horizontal road. But this time around, the cyclist is ascending a straight hill inclined at 3 degrees to the horizontal. And this is the mass here of the cyclist on the bicycle. Okay, that's what we have. And the question, it says that we want to find acceleration when he's traveling at 4 meters per second. Now remember, power is equal to what? Force times velocity. Now, if I remind you again, we have applied force here. That's what we have. And apart from that, remember they've said, the question says that resistance is still not changed. So this is resistance here, which is 16 newtons. Now, what do you know, you guys, when you're looking at Newton's laws, okay, Newton's laws, this is your weight here. This is mg. That's your weight. Okay. So we have this acting perpendicular. Remember, you have your R here. Okay. So this component here, which is a vertical component of weight, is this one here, the same. So this is a vertical component of weight. And the vertical component of weight is equal to what? The vertical component of weight, we have been looking at this every time. So this is going to be, the vertical component of weight is going to be mg sine theta, which is 80 times g is 10. Remember, that's the one we always use, times sine what? Sine 30 degrees. That's what we have. Okay. Now, before we continue with this, so when you multiply this, you find the vertical component, which is this one here. Now remember, power is equal to force times velocity. The question says power has not changed, so power is 240 is equal to F. We are given velocity in the question as 4. That's what we have, 4 meters per second. So it actually means that force is equal to what? Force is equal to 60 newtons. And this is a force here, which is 60 newtons. And then now what do we do next? Remember, we want to find what? We want to find acceleration. So we are using force is equal to mass times acceleration. Remember, this force here, which is in this formula, is a resultant force. It's not this force here. It's a resultant force. It's a resultant force. So resultant force in this case, remember, we are resolving forces in this way. Okay, so the direction is this way. So we'll start with this one, which is positive, 60 newtons, minus, we are going to say minus 16, because it's in the opposite direction, 16 and the vertical component, which we are getting from here, right? The vertical component. And this is equal to what? This is actually going to be equal to mass times acceleration. What's the mass? It's 80. What's acceleration? Are we given acceleration? The question is, that's what we are finding. We are finding acceleration, which is equal to A. So this vertical component, we can get it from here, right? 80 times 10 times sine 30. We use a calculator and find the answer, right? Yeah, we find the answer. So we're going to have 16 minus 16 times, this is 80. Sorry, this is plus here. So 80 times 10 times sine 30 degrees. That's what we have, right? And this is equal to 80 times acceleration. And that's what we are finding. So now you can see this is a number, this is a number, this is a number, and this is the variable that we are solving for. So from at this point now, you guys, you know, we can divide both sides by 80, and we're going to find the acceleration as 0.0266 meters per second squared. So that's acceleration. So that's acceleration. So we are done with the question on power. So that was a question on power. The other question on power Got a question on power. Remember, we've done 2017, 2019. Let's try to look for 2016 if we can find it. 2016, 2016, 2016. Okay, so it's here. We have it. So we have a question from 2016. And the question 2016 was question three. Question three. And I'm going to give this question as the question you're going to practice. So we've been given a car of mass 1000 kg moving along a straight horizontal road against resistance of total magnitude. Remember, we're given resistance. We are told to find in kilowatts the rate at which the engine of the car is working. Now remember, that is power. Power is the rate at which the work is being done. So the question is to find work. And we are given velocity, you guys. So you can see we are given velocity, we are given resistance, and what we need to find is force. So I'm giving you tips on what you're going to do. So you're going to find force, and you're resolving your forces horizontally. You get force, and then you're going to say power is equal to force times velocity. So I've given you tips on that. But there are a lot of questions from 2018 past papers that you have to do on power. You have to do the questions from 2018 past papers and other past papers. So practice the questions on power. Next time we'll look at energy. We'll not go to power. Thank you so much for your time, and enjoy your time and do the work, guys.